Ever wondered what really happens inside a nuclear reactor? Is it a ticking time bomb, or a marvel of modern science? Forget Hollywood's explosions. Refueling a reactor is more like a high-stakes underwater dance, choreographed down to the millimeter. Picture this. A reactor is basically a supercharged kettle, boiling water with the power of splitting atoms, no fossil fuels needed. One tiny uranium pellet packs as much energy as a ton of coal. That's the magic of nuclear fission, splitting atoms to unleash mind-blowing heat. That heat? It turns water into steam, spinning turbines and lighting up entire cities. Deep in the core, thousands of fuel rods, each loaded with uranium, keep the chain reaction humming. Control rods? They're the unsung heroes, taming the reaction like a maestro with a symphony. All of this is wrapped in steel and concrete, layer after layer of protection built to withstand almost anything. The result? Clean, powerful energy, delivered safely, every single day. Isn't that electrifying? Ever wonder why nuclear fuel rods need changing? If uranium is so powerful, why not just let it run forever? Imagine a campfire. As it burns, ash builds up, smothering the flames. In a reactor, atomic ash, fission products, clog up the process, blocking the chain reaction. Fuel assemblies are like batteries. They last about 4 to 6 years, but lose their spark as ash piles up. So every 18 to 24 months, engineers hit pause for a refueling pit stop. But here's a twist. Only the oldest third of the fuel gets swapped out. The rest, it's shuffled around, like rotating tires for even wear. But what happens to the spent fuel? It's not empty. It's still sizzling hot and radioactive, demanding serious care. Here's something cool. Most of it can be recycled. Just ask France. So, is refueling a crisis? Nope. It's routine, like changing oil in your car. This scheduled swap keeps the reactor humming, delivering clean, carbon-free power. It's all part of a carefully choreographed dance. And that's how nuclear plants stay reliable, decade after decade. Ready to see what happens next? The moment arrives. The reactor falls silent. Tension hangs in the air. How do you move hot radioactive fuel? With water, nature's perfect shield. First, the team shuts down the reactor. They flood it with meters of pure, borated water. The water cools. It shields. Every move is calculated. Slowly, the heavy reactor lid rises. Steam curls. The heart of the reactor is exposed. Fuel assemblies wait below, glowing with hidden power. A robotic arm glides into view. Operators guide it from behind thick glass. The machine grips a fuel assembly. It lifts. It moves with eerie precision. As the fuel travels through the water, a blue glow bursts to life. Cherenkov radiation. It's the signature of raw energy, barely contained. The used fuel slides into underwater racks. It will rest here, cooling for years. The blue light lingers, a silent reminder of the power within. New fuel assemblies descend, one by one. They slip into place, ready to spark the next cycle. Engineers watch every second. Monitors flicker. Alarms stand ready. The process repeats, slow, deliberate, never rushed. Human skill meets machine precision. Every step is a dance with danger, and a triumph of control. Okay, let's get real. Does refueling a nuclear reactor mean everyone's glowing in the dark? Spoiler. Nope. With the right precautions, it's about as dangerous as microwaving popcorn, if you follow the instructions. Ever heard of ALARA? It stands for, as low as reasonably achievable. Basically the nuclear world's way of saying, let's not take any chances. Here's a fun fact. Water is like a superhero cape for workers. It blocks almost all the radiation. And yes, those suits and dosimeters? Not just for show. Workers are monitored more closely than reality TV contestants. The refueling machine? It's got more backup systems than your phone. Power, interlocks, fail-safes, you name it. Every move is double-checked, triple-checked, and then checked again by experts who've seen it all. Here's a shocker. Nuclear workers get less radiation than airline pilots, so unless you're flying a plane, you're probably safer here. No water, no chain reaction. And borated water, that's like adding an extra lock on your front door. The real risk, used fuel, is tamed by, you guessed it, more water. Simple, effective, and no drama. So, next time someone says nuclear refueling is terrifying, you can tell them, it's all about smart engineering, not luck. And no, nobody's turning into the Hulk. Safe refueling keeps nuclear plants running, delivering clean, reliable power to millions. Each outage locks in up to 2 more years of carbon-free electricity, helping fight climate change. The process showcases the skill and dedication of nuclear workers, who keep our lights on and our air clean. Refueling is a critical, unsung part of the clean energy story. Every step reflects the industry's deep commitment to safety and public trust. When we understand the process, we replace fear with facts and empower ourselves to support a cleaner world. Safe refueling isn't just a procedure, it's the foundation for decades of clean energy and a brighter future. Let's champion safety, demand transparency, and celebrate the people who make sustainable energy possible. The future is in our hands, let's power it safely, together.